Good morning, sir. I am Deck Cadet Vince A. Paragele. Today, I'm going to plot the fixed position using two stars. So first, we are gonna get the DR position. So, the DR position is 44 degrees 10 minutes north and the longitude is 169 degrees 30 minutes east. So first, you need to plot the latitude and longitude. Since 44 degrees, so first, here is the 44 degrees. Next is the 10 minutes. Since this scale is by 2, so that means 2, 4, 6, 8, and then 10. We are gonna go to the 10 minutes mark. So this one. So you need to use your triangle. Here. So 44 degrees 10 minutes north. So here you go. So somewhere there. Next is the longitude. The longitude is 169 degrees 30 minutes east. So since it's by 2 again, here is the 169 degrees. So this means the 10, this one, 20, this one, and then 30. So that means this is the 30 minutes. So 169 and 30 minutes. So again, let's use our triangle, or if you have a parallel ruler, you can use it. So here 169 minutes 69 degrees 30 minutes. So here this is the 30 minutes mark, and then again we will use the other triangle. So 44 degrees 10 minutes, so it will meet here. So that's why I have the DR position here. After plotting the DR position, next we will plot the stars or the ZN, the direction of the degrees of the direction of the star. So our first star is it does have a 85.2 degrees. So I plot it using the triangle, and again, since this compass rose scale is by 2, I put it in the middle part. Here you go, 85. Since this is 90 and this is 80, this is 2, 4, since 85 cannot be seen in the scale, so we assume that in the middle that is number 5, since it is by 2, 2, 4, 6. So I have already plotted it. So 85.2 degrees. Then, since we have a DR position here, we will transfer this 85.2 degrees in our DR position. So again, using your triangles, you will move this one. So since I'm recording, I cannot use the other triangle, so I will just do it like this and move. So like that. So then you put a line. After putting at, since the star is going there, since it is 85 degrees, then we will plot our intercept. So what is our intercept? Since the given is 5.2 away. So what do you mean by away? So that means that away is away from the star. Since this ZN is 85 degrees, since the star is going there, so it means the intercept is away. So the intercept is 5.2. So first we need to measure using our compass divider. So we'll measure it here since this is 2 scale. So let's put it 5. So in the middle of the middle of 4 and 6. So here. After we measure that, we put it in our DR position, since it is away, not towards. Wait a minute. So here. like that. So that is where our first intercept. So why do we put here, not in the other way? Because it is away from the star or a heavenly bodies. So that's why I put my intercept here, not here. If it is towards, then I will put here in the opposite side. So after getting the intercept of the first star, we need to get the PL or the position line. So in order to get the PL, we need to have the 90 degrees from the intercept. So we use a triangle. Right angle is 90 degrees. Since in order so that our vertical degrees will not have some slight difference, so we will just add 90 degrees and minus 90 degrees on both sides here. So 85, the degrees of the star is 85.2 degrees. Since we will just add 90 degrees, so we will add going here, since it is the right angle, so let's put in the triangle. So here in the triangle, this is the right angle of the 52. So that means that the position line is something here going down. So so that we will have an accurate, we will just add 90 degrees. So that is the line. Wait. So this is the line. After getting the 90 degrees, you need to add. So we'll use the calculator. So 85.2 plus 90 degrees equals 175.2. So that means from the triangle, right angle, this line here is the 175.2 degrees. So this is the first PL. Then the other one is something here. So we must minus 90. So we'll use again the 85. So 85.2 minus 90. Wait. Minus 90 equals 4.8. Since we don't have that negative degrees, we'll minus 360. No. We will plus 360. So that's why we get the PL1 is in this side is 355.2 degrees. So why did we add 360? Since if we minus it, if it is not 85, when we minus 90, we can get something here, but it is negative, so that means it is over here now. So it is like one revolution. So that is why we minus it into 360. So I have also my own understanding. So the first thing I did is this one, 85.2. Since one revolution here is 90 degrees, so I will just add until I get here. So this one is 90. 90 plus 90 equals 180 plus 90 equals 270. So I will use it again. 270 plus 85.2, 355.2 degrees. So it is still the same. So it's up to you on how will you use. So after I get the PL, since I have a line 90 degrees here, I put a line and I will transfer it in our intercept of our first star. So since our first intercept is here, that's why I have a line here. So you'll use your pencil or anything, ball pen. So that is why I have a PL here, 355.2 from here and 275.2 degrees from here. So now that we have a PL, we will now get the ITP, intercept terminal point. So in getting the ITP, we'll just get the latitude and longitude. So where is our first intercept? So our first intercept is in here. So after using our first intercept, we will use the our triangles again for accurate readings. So measure. So since it is here, so that means that it is still 44 degrees. And when I use my ruler, it is still the same in the 10 minutes part. So that's why my latitude is 44 degrees 10 minutes north. And for the latitude, since it is here, not here, so this is means 30 minutes. So that's mean that this is 20 minutes and 10 minutes. Then since this is 20 minutes and it is something somewhere here, so I have assumed that this longitude have 169 degrees 21 minutes east. So that is our ITP. Next, for the second star. The second star have 183.5 degrees. So, first, we need to plot that. Since we have already the DR position here, we will just transfer the same process again. So, we'll move the triangle and we go here. After we go that, you need to draw a line. So, that is the part. After that, we'll find the intercept. So, the given intercept is 6.4 towards the heavenly body or towards the star. So, here is our star. So, that means towards our intercept is going something here. So, since we transfer it here, our intercept is from the DR position to here. Since the star is going there, so that means it's towards. And if it is away, we're going the intercept here. So, our 6.4, then we will use the same process again. Use the scale and measure the 6.4. And since it's towards, put your compass here and here. After that, you will mark your second intercept of the second star. After getting it, you will need to get the second position line again. So, from the second star. So, how to get? So, just like what I have said from the first star, it is 90 degrees. Since it is 185, so 90 degrees, it is something here, like that. So, for accurate, we just need to add 90. So, again, I will not just use calculator. You can do it from your own. So, 183.5 plus 90 degrees, since it is going here, so we will have a 270 degrees 0.5. And minus 90, since it is not over to 60 or not round, it is still there. So, we will just minus 90. So, 183.5 minus 90 equals 93.5 degrees. So, we have now our position line. And again, we just transfer it from our intercept. Since our intercept is here, we just transfer here. After transfer then, and draw a line, that is our PL. So, after getting our PL, we need to get our second ITP. So, again, we need to latitude and longitude using our triangles or parallel rulers. Here, so, my second ITP have still 44 degrees north and 1 minutes north. Why? Because it is slightly above here. So, I will just assume that that is the part using the calculator. I mean triangles. So, here. So, after that, our longitude. So, again, ruler or triangles. So, since it is in the 30-minute mark using your triangle here, so that means that still 169 degrees 30 minutes east. So that is our second ITP. Next, since our goal is finding our fixed position, so in the procedure in finding the fixed position, it is the intersection between the two PLs of the two stars. So where is the intersection? The first PL, the second PL. So this is where it intersects. So this is our fixed position. So you must remember that in order to get the fixed position, you will always get the latitude and longitude. So again, use our triangle. So we got 44 degrees 4.3 minutes north. The longitude is 169 degrees 24.8 minutes east. So that is all, sir. Thank you.